Hi and welcome. Thank you for spending the next 30 or so minutes with us. My name is Valerie DiMartino and I'm joined today by George Logorakis. We're here to help you better understand the opportunity of network automation as it relates to network design compliance to ensure your network is configured correctly to prevent outages. But first, why should you care? We've spent a lot of time talking to our customers, and we've learned what their top 8 network challenges are for day 2 automation. So we've created a webinar series to focus on these use cases. Today's webinar is focused on how intent-based network automation helps when auditing network designs, best practices, and rules for compliance. Your business depends on your network to run efficiently, and this is increasingly important in our fast-paced world. But inefficiency due to manual network operations can inhibit your ability to support the business. As networks expand rapidly, so do the number of problems, the time it takes to solve them, and the tools needed to support all of it. The stakes have never been higher. The inevitable network outage, brownout, or even minor glitch can result in loss of revenue and reputation of the company. Every second counts. And with complexity growing, you have to get control now. With network automation for inventory and a dose of prevention, IT admins can get an understanding of the tasks of their networks at any given time. Network understanding is the foundation for operating your network post-config and deployment while leveraging just your existing resources. For most, compliance is a moving target. Most network audit problems can be traced back to 2 general causes. It's difficult to prove compliance. Even if you're operating within the rules, you don't have up-to-date documentation that backs you up. And second, you run into compliance drift. It's hard to keep track of how the constant changes to firewalls, policies, rules, and exceptions affect compliance, so your network reverts to an out-of-compliance state. Our Day 2 network automation platform was built specifically to help NetOps better align with the business needs on an ongoing basis, not just Day 1. According to Gartner, network change requests are common, ranging from upgrade the bandwidth at a branch to deploy a new server in the data center, etc. However, approximately 70% of network configuration activities, like changes and associated pre- and post-change activities, are manually driven. This leads to configuration drift, as many manual changes are unplanned and undocumented, and often aren't cleaned up after the fact. Further, manual configuration changes are ripe for human error, as they estimate that 2% of manual changes result in some form of error or anomaly. But there is hope. If you like NetBrain for mapping your network, you'll like us even more for our intent-based automation. Network intents manage expected results rather than relying on the traditional device-level management approaches. Network intent is the intent of your live network in addition to the associated diagnosis logic to detect deviation of those intents. So managing the network as a collection of tens of thousands of intents, not 1,000 devices, is the path to network automation. By abstracting the underlying network details, you can translate business intents to network intents, and then ultimately to device configurations. By combining network intents with automation, Day 2 network operations become scalable, a huge value in the era of constrained skilled resource availability. NetBrain differs drastically from other device-based network management approaches because it focuses on application needs and services in use. The Problem Diagnosis Automation System, or PDAS, manages your hybrid network as a compilation of network intents to directly support IT service delivery needs. The system is the industry's only intent-based hybrid network automation and visibility platform, focused on automating network problem diagnosis at scale. In its fourth generation, it's now being used by thousands of customers worldwide to manage millions of network nodes and automate millions of network service tickets every year. Network ops teams like yours rely on NetBrain to help them deliver business-critical IT services more reliably, with fewer human errors, more consistency, and at a lower cost. To put it simply, NetBrain reduces the overhead associated with managing your network through the deep understanding of network intent to reduce the number and duration of network service tickets. Using the system, it includes rich visualization of any end-to-end network while providing the foundation to build and apply network automation to any operational task by anyone through our unique no-code approach. It enables you to solve any problem once by capturing the diagnostics and remediation workflows without any programming, and then reuse that knowledge for each subsequent occurrence of the same or similar problem. Day 2 automated network operations allows you to manage your hybrid network by capturing, verifying, and enforcing network design intents to ease problem diagnosis and ensure those conditions are maintained. First, it captures network intent with dynamic mapping by encoding the hybrid network to establish the network intents of each component. It then verifies the policies and the best practices of your network through a set of diagnostic processes needed for each network intent to establish compliance. And then it enforces network design to maintain benchmarks with continuous validation that all defined network intents are being fully met. And on top of that, NetBrain's automation library service offers more than 60 intents for the most common problems of modern enterprise network operations. NetBrain auto-discovers your entire hybrid network, including traditional components, software-defined LAN and WAN, and cloud, making all of this information about configuration, performance, and flow of traffic easily accessible to any operator or engineer as part of its visual management and automation console. NetBrain's discovery engine continuously inventories all devices, their configurations, the connectivity, and the protocols, including IPv6 addresses. The result is an exact digital twin of the end-to-end network in real time, every device, every platform, every firmware version, and it contains all the topology data and baseline configuration and performance analysis. Then it provides this information in an easy-to-navigate and intuitive visual management console. NetBrain verifies intents with a triggered automation framework that responds to external events like tickets from an ITSM such as ServiceNow and events from network monitoring tools like Splunk. It has an interactive automation framework that records network engineers' diagnostic steps as they do them to create automation they can use by getting data from devices, looking for changes, and monitoring and alerting threshold changes. And it has a preventive automation framework that enumerates any network as a series of application or network designer goals and provides the network for problem diagnosis based upon deviations from the intended outcomes. It then enforces all of this by running automation so that your engineers and operators can work on more important tasks. In order to effectively manage your network, you have to know what's in it. So foundational to the NetBrain platform is its digital twin that enables intelligent and well-informed day 2 operations across your hybrid network. And since the network itself is defined by the intentions of what it delivers, the digital twin becomes a lens into the real-time operations of your network. With this tight connection between the two, network automation can be applied to the digital twin, which is then reflected in the network components themselves. NetBrain redefined the concept of network mapping by offering the industry's only real-time dynamic network maps, which continuously discover, model, and visualize the entire hybrid network from the public cloud all the way down to the network edge. And because the data model also includes the ability to do historical data comparisons, it's easier than ever to identify changes and potential sources of problems. Operations teams can now use network mapping software to visualize, navigate, and investigate and troubleshoot hybrid network issues in a single consolidated view, including data programmatically collected from third-party monitoring applications. Whether you're just trying to understand your network better to do troubleshooting or planning, or if there's compliance regulations or standards that you're trying to verify and auditors are coming in and wanting to see documentation, you need lots of it. And it needs to be up to date. And this documentation is usually comprised of Visio diagrams and design documents in Word, if you're lucky. The problem most organizations are facing is that their diagrams are almost always out of date. So NetBrain helps with producing and maintaining an accurate, up-to-date network data model. It does dynamic mapping with contextual maps and dynamic paths to create dynamic network maps of physical, virtual, and logical networks. And if required, you can export it to Visio and Word in one click. It does inventory reporting of all your network devices, and it has a one IP table that allows you to see and share every networked route and subnet in your environment. NetBrain verifies the network and application architect's design intents to ensure the hybrid network is optimized for all application paths critical to the productivity of your business. You can automatically maintain the compliance of the network by scheduling recurring application traffic path verifications to detect deviations from a golden path, changes from a previous state, and deviations from network intents themselves. You can prevent configuration drift by verifying routing and security policies. NetBrain also displays all of your applications and their network paths and intents together. All traffic paths are organized by applications or services. With NetBrain's application assurance, you can view the status of paths and intent checks, statistics on failed or changed paths, and filtered rows based on results. NetBrain enables operators to perform network investigations quickly with path calculations and mappings, creation of new applications and paths, or importing and exporting of application and path data. NetBrain provides one place to ensure the network consistency required by applications is being met and is made available to all of your network operations teams. Another thing that helps maintain design compliance is having a good change management process. The reason is that the vast majority of network issues, including service outages, are the result of change management errors. As the number of devices and complexity increases, it's harder for you to foresee the impact of the changes. So NetBrain offers a comprehensive lifecycle network change management capability that reduces the risk and the cost associated with production network change processes. With NetBrain, you can make highly informed network changes and verify their impact on other business applications. Network operations teams can deploy critical network configuration changes at scale while instantly verifying their success and overall impact. NetBrain helps you maintain compliance of the entire production hybrid network. You can proactively guard against misconfiguration by triggering automatic validation of network changes against golden baselines. And you can automatically run a series of security compliance steps to ensure that changes haven't caused compliance drift. NetBrain empowers you to make highly informed changes interactively, execute commands automatically, and then proactively verify the impact of these changes on the rest of your business applications. It gives network engineers a single place to keep track of changes in a way that's fully auditable and adherent to existing business protocol and approval processes. There are many benefits to automating network change management. First, you can make network changes without fear of disruption. So if you have before and after snapshots, you can verify the impact of the change and ensure that there's no adverse conditions afterwards. You can verify application and traffic flows, run diagnostics, and even leave notes for other users. This allows you to quickly see any unexpected impacts resulting from any change. You also get a safeguard that the network is free from human error. So if there's any types of conflicts, you can easily revert changes that may adversely affect the network and its applications. You get a full log of every change detail, and you can have a rollback, which is stored as a process with commands to undo any changes to any point in time. You can also help with maintaining regulatory compliance of the entire production network for design standards or security regulations. You can proactively guard against misconfiguration by triggering automatic validation of network changes against golden baselines. And finally, you can speed configuration updates with scriptless device commands in real time. This allows you to quickly visualize any changes impact on the network and execute changes across all devices. You can then automatically update the network documentation, export it, and then there's also templates that you can use to help with standardizing your change management processes. Compliance checks are necessary but time-consuming. Devices out of compliance are serious risks. NetBrain's adaptive monitoring system detects early warning signals by customizable software probes before the end user application experiences negative impacts. NetBrain can automate compliance checks across sites with a preventative automation framework that includes adaptive monitoring and network intent clusters. NetBrain's adaptive monitoring automation uses a set of scalable hierarchical logical flash probes as monitoring units to detect when an anomaly occurs on a single device via SNMP and CLI data polling and advanced anomaly analysis algorithms. As soon as one detects an anomaly, the system will take immediate action to execute the predefined network intents, the results of which will provide critical references to the root cause analysis and speed up the troubleshooting process. Adaptive monitoring leverages flash probes to identify certain network alerts. Flash probes can be used via SNMP and CLI parser variables or can receive alerts directly from external systems such as Splunk. Unlike the traditional network monitoring tools which use SNMP for monitoring, you can create more network-specific probes for monitoring and identifying potential problems. Network intent clusters allow for scaling network intents through a system that NetBrain has developed. This provides automated diagnosis and rule check triggered by that early warning alerts from a set of logical probes. NetBrain's preventive automation framework is different from the traditional monitoring systems because it's designed to enforce design and security rule checks automatically, not monitoring system errors. It's customizable based on network designs and not a one-size-for-all. And it can serve as next-gen compliance check solutions. It's a 24/7 compliance check. Remember, your network is only as good as the next network change. The task to audit and enforce best practices, application, and architectural rules is the key to ensure network security and uptime. Most organizations leverage manual review or periodically executed compliance checks to achieve the above goals and often fail in doing so. NetBrain encodes best practice rules with your network intent and then monitors rule violations proactively on your behalf. This mitigates any performance risks while you work on more important things. And now we're going to have a demo of some of the things that you can do with NetBrain to enforce design compliance. I'll hand it over to you now, George.
Thanks, Valerie. So this demo portion is going to go over how NetBrain handles compliance from two different aspects. The first is mapping and documentation, and the second is using automation, specifically intent-based automation, to automate your compliance checks on your devices in the network. So let's start with the maps and documentation. So network maps are a common deliverable for compliance projects, and creating them often takes hours or even days of work. Using features like sitemaps and network context, we can create comprehensive network maps in a significantly shorter amount of time. So let's go ahead and see what that looks like. So from in NetBrain, I'm going to open the network context pane, and I have the ability here to look at different categories of my hybrid network. I'm going to stick here to the physical network, and I'm going to select a router. Now, you'll notice when I select a router, NetBrain is going to automatically generate context maps. And these maps are showing the device in different contexts within the network. So you can see here I have one for layer 2 topology, one for layer 3 topology, so showing the layer 2 and layer 3 neighbors respectively. And I'm also getting this map up here called CXL lab. This is an example of a sitemap. So we can also see the associated sitemap right here. So sitemaps are built based on all the devices within a site. So NetBrain allows us to dynamically create sites and use dynamic criteria to group the devices into sites. So think, you might have a naming convention for devices in a certain geographical region. So you can group all devices with that same geocode in the host name. So BOS for Boston, for example. All of those devices can be grouped into a site. And once that site is created, NetBrain will automatically generate a site map, which is what we're seeing here. So I can go ahead and just open one of these maps, and I'm automatically going to have a full map that I can work with. Now, you'll see that this map may not be as clean as we want for a deliverable. So we can clean it up and then be able to continue our work on the compliance. So if we clean it up, it can look something like this. You can see it's a bit of a cleaned up version. And now what can we do with this map now that it's been created and we have it in a format that is satisfying our need? We can go to the map here and we have export options. So we can export it to any of these 4 formats: an XMAP, a Word, a Visio, or an image. Now, XMAP, Visio, and image are going to perform how you would expect. You're going to get a file that you could then embed into your report, or in an image, you could have that as part of the report, the image showing the map of the network. The Word export, however, works a bit different and is actually a bit more powerful for the documentation side. So if we go ahead and select that one, I'm going to go to advanced settings to show you that when we export as Word, NetBrain's actually going to automatically export a complete report around the map and the devices within that map. And we have 7 sections here that we can customize. The first section is the topology map. The second section is device configuration. So this is where we can actually pick to either have the full configuration of each device in a zip file or a certain configlet. Device asset data. This is where we can actually choose what asset data to be displayed in a table within the report. Layer 2 interface asset data. So this is more asset data, but pertaining to layer 2. And again, we have a list of other fields we can add to this report or remove. So this table again is customizable. Layer 3 interface IPv4 asset data. Same idea as the layer 2, but now we're focused on layer 3 information, and again have the ability to add and remove different fields as we wish. And then the same for layer 3 IPv6 information. We have a table for that as well, for that asset data. And then we also in section 7 have the ability to add other types of tables to the report based on maybe what devices we're pulling in or what data you would like. So NetBrain, through this exporting to Word, will actually give you a great shell at the very least of a report that can be used for compliance. So we're automatically helping you in the reporting process as well and pulling in all the important information. Now, if for some reason you don't need a map, but you would still like documentation or these tables, we do have an inventory report section that will allow you to automatically generate and export certain asset data from your network. So quickly, I want to show what one of these reports looks like. So I have one saved here that I'm going to quickly open. So this is what the export in Word looks like in NetBrain. So you can see that NetBrain's exported an entire report with 7 different sections. So here's that first section, as I mentioned, with the map and an embedded Visio. Device configuration, we have it in those files. And we have the different tables. And you'll notice that you'll have a full, the full table will be displayed in the report, but you'll also get an Excel file with that table as well. So we provide a lot of options in this report right out of the box. And we can see that for each of the different types here as I scroll through and see all the information being pulled in from this example map, right? So all those devices on the map are now within the report, and we're seeing all different information. So that's the mapping and documentation portion, but what about the actual compliance checks, right? Making sure our devices fall into our compliance policy and are in line with our security policies, or maybe it's a third-party standard like a NIST compliance or a PCI compliance that we're working on. So we can achieve that through network intent or intent-based automation. And intent-based automation will automatically perform configuration compliance checks. And as a reminder, or for those of you who may not be aware, network intent is no-code automation that validates and verifies network design. So this automation that I'm showing you here was created without any sort of scripting or programming involved. And what it's doing is actually performing a variety of 10 plus different compliance checks. And it's everything from something that maybe an organization would has a requirement for, like a banner, and all the way to maybe some security best practices like ensuring SSH is configured, ensuring access lists are not allowing traffic using certain protocols that they shouldn't be allowing, or it just allowing traffic in general that they shouldn't be. And then of course we're also looking at the login. We can make sure that we're not allowing any logins from insecure protocols, and we can see that that's also and we can see here on the right that those red highlights are where the device is out of compliance, and a green highlight is where it is in compliance. So this device, for example, has a lot of compliance issues that need to be solved. But what you'll notice from this this automation, as you're looking at the elements of it, is it's only happening on one device. So what about if we have hundreds or even thousands of other switches on the network that we want to run these compliance checks against? Well, in this case, we can use what's called the network intent cluster. The network intent cluster is going to allow for those compliance checks to automatically be scaled across the entire network. So how is this done? Well, you need to provide NetBrain with a few key pieces of information, which is the intent we wish to scale, the logic you want NetBrain to use to scale out that intent, and then also criteria to determine which devices an intent will be created for. Using this information, NetBrain will automatically create what's called member intents. So member intents are these automatically created network intents based on the criteria. So you can see in this case, I've created 58 member network intents, and each one is going to correspond to a different switch in my network, but it's all going to perform the same checks. So NetBrain's automatically created 58 intents based on one intent that I made for that one switch. Now that we have automated these compliance checks and scaled them through a network intent cluster, what are some of the ways we can actually utilize the automations? Well, one way we can use them is through change management. So they can be run in conjunction with your change management process or the change management module from NetBrain to verify that those compliance-related changes have been successfully implemented. So think of it as you make your change, then you run this after to verify your change. Another option for this is to use preventive automation. So after your compliance checks have been completed and necessary changes implemented, preventive automation is going to help ensure that your network does not drift back out of compliance. So you're not seeing these issues or more issues the next time you do compliance checks. So let's dive into this. So here I'm in the preventive automation dashboard. And within this dashboard, we can view the preventive automation tasks being executed for each device in our network. So I'm going to pick a device here so I can look specifically at what preventive automations we have running on it. So if we look at this US Boston switch 1, for example, we can see here compliance checks being run using a timer. A timer will execute any associated automations, in this case the compliance checks, at a user-defined frequency. NetBrain provides 3 of these timers out of the box. High frequency, which is every 4 hours, medium frequency, which is every day, and low frequency, which is every week. Custom timers can also be created to group different types of automation tasks. So as we've done here, we've created this compliance checks timer. That way all of our compliance checks can be grouped into a weekly timer, or a daily timer rather, that will allow us to run those checks every day and ensure that our devices are in compliance. Now, we could also have associated this to a probe, which is an automated check in NetBrain that's also on a preventive automation, but they're based on more discrete conditions. So you could have a probe looking for if the configuration has changed, since the last known configuration, and if that is the case, then you could trigger your compliance checks to ensure that configuration change has not put the device out of compliance. Now, how do we get alerted when these changes happen, right? If a device is out of compliance and preventive automation catches it, how will we know? Well, there's 2 different ways. The first way is email. So we can email either an individual's email or the network operations team email group, for example, and they will receive an alert that this specific automation that was run preventively has found issues or an issue. The other way is that we can have these preventive automations trigger incidents in your ITSM solution. So you can also have tickets and incident records generated based on these preventive alerts, which will also help maybe for compliance tracking purposes. And that is the end of my demo, so I will pass it back to Valerie for Q&A.
Thanks for that demo, George. So in 2019, the City and County of Denver concluded an audit that highlighted the need to enable dynamic ARP inspection for thousands of network devices in a 2-month time frame. Manually turning this on for many of their devices was not feasible in their time frame, without hiring and quickly ramping up many new team members. Additionally, the city and county needed to set and enforce standards on all network devices and intelligently manage their Cisco Smart Licensing environment. They quickly realized that this would need to create a customized dynamic ARP inspection process for each device that only requires the gateway for an IP subnet. That still means having to go through and look at thousands of switches to figure out every port connected to other devices on the network. If they had done this manually for each device, this would have required a burdensome amount of labor and have been highly error-prone to the complexity of the access levels across IP gateway lists. Once they found NetBrain, they were able to build a parser to audit device configuration and leverage NetBrain automations alongside Python and Ansible integration. They can achieve compliance above 98%. In addition, they were able to meet their audit deadline with time to spare, and they also saved $75,000 by not having to hire contractors to do this work manually. Beyond this immediate cost savings, the City and County of Denver also reported that they saved 150 to 200 hours of manual labor by automating network standards enforcement. They achieved 98 to 99% standards compliance on firmware versions. They automated inventory and segmentation of Cisco Smart License devices. And they dramatically reduced the ongoing audit and compliance monitoring reports for one VRF from 100 hours to 10 minutes. It's really amazing, the power. Please find lots of great resources on our site and how you can get started on your own or talk to one of our experts further.